Hello everyone, welcome back to my YouTube channel. My name is Sagar Utekar and this is day 2 of our free CK series. Today we are going to discuss very important topic, Kubernetes, and which is important for a CK exam as well as for the Kubernetes interview. These are very commonly asked questions. What is Kubernetes? Why do we need Kubernetes? What it extra provides over the Docker, the containerization platform? What are the different components of the Kubernetes architecture? Why Kubernetes removed the support for the default container runtime Docker? And what are the replacement for it? We'll discuss all those questions one by one. We'll take an example of the Amazon website. This website code is divided into multiple microservices. Just consider 2 or 3 microservices. It's a logins microservice, payment service, and the card service. Okay. So if we take a actual process for the containerization from the previous video, what we used to do, like we need to write a Docker file. Using that Docker file, we can create a Docker image, and that Docker image can be used for running containers, right? So, but Amazon is a website which is widely being used. So having a single container for each microservice is not enough. And running all those containers on the same host machine is also not enough. What if the host machine where we have the Docker daemon running and our containers running, it goes down? Our entire Amazon application won't be accessible to any of the user. We don't want that. We need a better platform where we can host our containers um, on different machines. Even if one of the machine goes down or the one of the node goes down, it should be scheduled on the other operable node, and our user should not get impacted. So that is our first thing. Okay. And having a single container per microservice is also not enough. Consider this same example of microservice when there is a festival, Diwali or any other festival. Amazon receives so much of traffic during that time, and if that container goes down of one of the microservices, the application won't be accessible. The user won't be able to perform that or access the application. So we need better approach. We need to have the multi-containers approach, right? So we have the Docker image, which can be used to create a multiple containers across different hosts. But now the problem is how all these containers will communicate with each other. We need a platform which will take care of the communication as well, right? The next problem is now we have the multiple containers, but the user's request will go to which container. We have the multiple replicas of the card service. Well, user service goes to the cart 1, 2, or 3. Users should not be worried about that. We need a platform which will take care of the load balancing and the service discovery. Whenever user is accessing the login page, doesn't matter in the backend how many containers are running, user should not be known for all those things. So that's where our Kubernetes favorite and most widely containerization orchestration platform comes into picture. It is originally developed by Google, and they open sourced it in 2014. Now it is maintained by the organization called as CNCF. Okay. The one of the selling point I feel for the Kubernetes is that it is portable and extensible. On top of what Kubernetes provides, choosing the CRDs and other features, existing features, you can create your own resource based on your requirement. So it is not limited for what it is currently providing. It has very wide support from the open source community. Um, and one more feature is that you can install Kubernetes cluster on any type of hardware. Like you can install Kubernetes cluster on your laptop, You can have it on your virtual machine, physical servers, as well as in the cloud providers. If you want to have the clusters created or the made up of different type of uh, virtual machines, physical servers, or we can say it as a hybrid model, that is also possible. You can do that. So those are the features for Kubernetes, and those are the problems Kubernetes is trying to solve. Okay, so just to list down, Kubernetes provides the service discovery and the load balancing. Storage orchestration, you can use the local storage, you can use the cloud provided storage as well. It also helps for the automated rollouts and the rollbacks. So for example, card service got some new feature. We released that feature now. That feature is deployed in production environment, but somehow we push the buggy code and we want to roll back to the previous version. That is very much possible with the Kubernetes. We will check out what are the deployment strategies and how to take care of that, so that minimal users will get impacted with your new releases as well. There are other features like a self-healing. Kubernetes also helps you with the secret and the configuration management, which means you don't need to hard code the secrets or the configurations required for your application inside the code now. Kubernetes has its own resources called as secrets and the config maps, which you can create, put your secrets, and have it in Kubernetes cluster. Whenever your container needs all the secrets and the configuration, you can mount those inside your container. Okay. It also provides a batch execution, horizontal scaling, support for IPv4 and IPv6 dual stack. Uh, so if you want to run your application at particular time interval, or you want to have some kind of job, that is also possible. Kubernetes have the jobs and cron jobs features, other resources provided. I think those are the features you should definitely tell during your Kubernetes interview. Okay. The next question is Kubernetes architecture. Architecture. Yeah. So first understand Kubernetes can be installed as on a single node as well, and it can be installed on the set of nodes. And when you create that cluster, either with a single node cluster or the multi-node cluster, the grouped nodes is called as cluster. Okay. There are two main categories: control plane node and the worker node. Control plane node is, you can say, it has the main logic of managing your entire cluster. It will have the all components which are required for scheduling the pods on your Kubernetes cluster, maintaining the desired uh, replicas, as well as how to store the data related to your Kubernetes, etc. So we'll talk about all those components in detail one by one. The worker node are the nodes where your actual application containers run inside your Kubernetes cluster. But before going ahead, I want to make sure you understand the main point in the Kubernetes, which is the pods. So in Kubernetes, you don't run containers directly. You create a pods, and inside a pod, you can run your containers. One pod can have the multiple containers as well. So all those details we will discuss about the pod much more in detail in upcoming video. Just for now, so just understand the pod is a minimal component or the resource you can create inside a Kubernetes cluster. Okay. Yeah. So let's talk about the Kubernetes components. So this is a architecture diagram. You can consider this one or the on the right side. Anyone is fine. Like both are the same. Okay. So whenever you run any command from your command line tool called kubectl, or when you hit a API request to kube API server or Kubernetes cluster, it will always go through the kube API server. And that's why kube API server is a main component or the central component for all the communication between from the inside uh, from inside and outside the Kubernetes cluster, which means when you hit any command, kubectl get nodes, kubectl create deployment, it will always go from the kube API server. Okay. Uh, yeah. So that is a central component. It performs various validation and it processes your request whether you are passing correct request or not. And based on that, it will perform the next set of operation. Okay, which means if your Kube API server is not working, you will not be able to interact with your Kubernetes cluster. And you need to have the proper authentication and authorization to communicate with your Kubernetes cluster. Only if your Kube API server allows, then only you will able to perform any operation in your Kubernetes cluster. So we will check how to authenticate and authorize for our Kubernetes cluster and how Kube API server performs its role in that authentication and the authorization process and the validation process as well. Okay. The next component I want to highlight is that the etcd database. So consider this is a database of the Kubernetes cluster where all the information of your Kubernetes cluster gets stored, which means you don't really want this database to be hacked or exposed. It will store information related to your Kubernetes cluster, such as the node information, your pod information, deployment information, and everything related to networking configuration, storage configuration, and everything. So, which means Kubernetes API server is a component where your API request will come, and whenever it needs any information, it is going to check that into the etcd database. So it will ask etcd database whether it has that information or not, and then will update the etcd database. There is dedicated chapter into your CKA curriculum on etcd database management. So you need to take a backup of etcd, you need to restore it for your Kubernetes cluster. And yeah, this is very important topic. So we will have the dedicated video on how to take a backup of etcd and how to restore your etcd data backup. Okay. The next component I want to talk about is the Kube Controller Manager. Kube Controller Manager is one component. It is a single binary actually, and it has multiple different controllers. So for better management or for easier management, Kubernetes team combined all the different controllers into one single binary. So what are those controllers? So for managing nodes, we have one node controller. For deployment management, we have a deployment controller. For namespace management, we have the namespace controller, and many more controllers are present. So the responsibility of the controller manager is that it keeps on checking with the Kube API server for the discrepancy, and if there is any change happening into etcd, and is there any new request coming in for creating a deployment. If there is a new request, it will ask a deployment controller to create a replica set, and for replica set, controller will take care of creating a pods for the new request. Okay. So that is the job of Kube Controller Manager controllers. It makes sure that the desired state always matches to the actual state of your Kubernetes cluster, which means if you need a particular number of pods, and if they are not present, it will make sure by using the specifications you have provided, it will try to create those number of pods. Okay. The next component is Kube Scheduler. So Kube Scheduler is a component which is actually important for scheduling your pod to the suitable node. It doesn't create a um, pods or the containers. It uses the algorithm, and based on different constraints such as resource availability, hardware resource, software constraint, affinity, anti-affinity rule, or taint tolerations rule. It will figure out the best possible node, uh, and then it ranks all the available nodes. It provides the score for the available nodes, And once that calculation is done, it will inform Kube API server, okay, this is a particular node, this is a perfectly suitable, and you can take a next action for creating a deployment of the pod. Okay. Kube API server will get that information, store that information into etcd, and the next operation will continue. One more optional component which runs on the control plane node, which is a Cloud Controller Manager, CCM. Why I'm saying this is a optional component, because you don't need to run it always. If you have the workload or the cluster into your cloud, then only you will need to install this Cloud Controller Manager. This is a separate project maintained by the Kubernetes. So if any new cloud provider wants to provide the functionality to manage the nodes, load balancer, networking, then they can add their controllers into that GitHub repository, and then cloud. Once you install the Cloud Controller Manager, it will take care of managing all those cloud resources for your Kubernetes cluster. Okay. Next thing we want to discuss about worker node components. So we already discussed about the control plane components. Just to summarize, so we discussed about uh, Kube API server, then its communication with the etcd to store the data, and then Kube controller manager, which is a single binary with multiple different controllers, which always make sure the desired and the um, actual state of your Kubernetes gets maintained. Kube scheduler is a component which will help Kubernetes to find out the suitable node for running our pods or the workloads. And yeah, so and then Cloud Controller Manager. So that is um, optional component for managing the workload on your cloud, okay, respective cloud. The worker nodes. Let's talk about the components of the worker node. So worker node have the components such as kubelet, kubeproxy, and the container engine. So let's talk about the kubelet first. Whenever kubelet is a crucial component on your worker nodes to run the pods and to send the report of your node and the workload running on that node back to the API server. So it will always time to time, actually, it will send the report back to the API server, and then API server will store that information into etcd. Okay, so it registers worker node as well as it also configures the local node to meet the parts requirement. So it doesn't actually start your container, but it only set up the environment on that node. For example, if your pod needs the storage, if volume, if your pod needs some secrets, if your pod needs some configuration, so it will make sure all those things which are required to run your pod are available on that node. Okay. Then kubelet will talk to one more component called as container engine, which can be either container D or cryo, as we discussed in the beginning. So Kubernetes has removed the support for the default container engine. Yeah, it was not following the um, container runtime interface. Um, what do we say, like rules, CRI rules. That's why that has been removed, and we will discuss that in detail in some time. What are other reasons to remove that? So kubelet will talk to container runtime. Uh, let's consider container D is a runtime which is running on our worker nodes. So container D runtime will talk to one more component called as runc, which will actually create your containers on your worker nodes. And that's not it. So kubelet will keep on checking the state of your containers time to time from the container D and send back the reports to the Kube API server. Same as Kube controller manager and the different controllers will keep on checking the status of your Kubernetes cluster through the different controllers, and make sure the actual state and the desired state is always maintained in your Kubernetes cluster. There is one more component called as kubeproxy running on your worker nodes. Uh, so this component helps us for maintaining the network uh, for our different pods running across the different nodes. Whenever you create a pod, it will create a IP table rules which will map the rules for service to pod forwarding, a request forwarding between the service and pod, and it will also set up the rules for communication between the different containers running on the different host of your Kubernetes cluster. Okay, so that is the entire Kubernetes architecture, and you can explain with this Kubernetes diagram as well. You can design it. So just to summarize, I have added a couple of more nodes in this, if you see. So as we discussed, so Kube API Server Controller Manager, all those components are running on your Kubernetes cluster as a pod in one of the namespace called as Kube System. And this part is very important for you to understand how to check the Kube API Server pod and how to check the configurations for it. So you need to run one command on your Kubernetes cluster, kubectl git pods -n kube system, and you can check for the API server pod ID. You can log into that pod and check the service configuration file on the etc Kubernetes manifest kube API server YAML uh, is the file for your kube API server pod. Okay. Similarly, you can check the uh, file for other components as well, controller manager, scheduler. The only difference is for kubelet. Kubelet doesn't run as a pod, it runs as a systemd process. So you need to log in into the worker nodes and check the valid kubelet config.yaml file for the kubelet configuration. Okay, and everything else you can check as a pod. One more difference I see is that kubeproxy, which runs as a daemon set on your Kubernetes cluster. So you can get um, the daemon set and the associated pods for the daemon set on the worker nodes and check the configurations for the kubeproxy as well. Okay. Yeah, so we discussed that we need to now we are not using Docker anymore for our as a default container engine. Let's say we have the container D. You can use the CryCTL or CRI-CTL for managing your containers running inside your Kubernetes cluster. So we'll discuss some of the important commands for from the CRI-CTL. Okay. Let's talk about Docker versus Container D and also why Kubernetes removed the Docker as a default container engine. Okay, so this is the architecture of how Docker interacts with the Container D. In previous video, we discussed that Docker is a platform uh, which provides different tools. It provides the Docker CLI, Docker API, security, networking, volumes, and then compose, authentication, build, and everything. It also have one more component for managing your containers is called as container D. It's a container runtime used by the Docker. Okay, and containerd communicates with a runc for actually creating your containers, right? That is the architecture. So in Kubernetes, also this was happening. It was the Docker was getting installed entirely with a components such as these network volumes and Docker CLI and everything. But the actual thing which Kubernetes needed was the containerd or the container runtime only. Kubernetes has its own components for managing the networks and volumes and other things, even authentication. So these extra tools were getting also installed, and that's one of the reason for removing the Docker from the as a default container engine. Okay, so what is a container D? Container D is also open source container runtime designed to manage and run containers by leveraging operating system kernel. So what happened exactly? In March 2017, Docker extracted its core container runtime and created this standalone project, and it donated it to the CNCF organization. Okay, sorry. Uh, and by February 19, Containerd reached the graduated maturity level in the CNCF. Now, what CNCF and the Kubernetes community thought is that since we don't require other functionality of the Docker, we only need the Containerd, which is required for running containers, then why to overload all these components, right? Yeah, that's a one reason. Then Containerd is recognized as an industry standard container runtime, and it is actually following the OCI compliant policy. So, and Docker is the tool or the platform which was not following the OCI compliant container runtime policies. Docker only follows the image spec, not the runtime spec. Containerd is a project which follows the runtime spec. So Kubernetes and the CNC have mandated that if the runtime follows the um, OCI standard, then only it can be used as a container engine in the Kubernetes cluster. And Containerd is one of them. So you can use the Cryo or the Containerd, but you can't use the Docker as a default container runtime now. Okay. So I have listed down all the things which we just now discussed. So whenever you run any command on the Docker CLI, it will go to the Docker daemon. It will validate the request. It will check all the things. If the image are not present, then it will pull the image locally. Then it will forward the request to the Docker daemon. Sorry, from the Docker daemon to Containerd, and then Containerd will forward the request to the runc for actually creating your containers. Once the containers are created, then Containerd Containerd will monitor the container status and manage the life cycle accordingly. So this is the basic difference between runc and the container. Okay. Runc provides the essential functionality for creating and running container, and Containerd offers a complete environment for managing and orchestrating container workloads, which is built on top of runc. So runc is kind of, you can say, is part of Containerd. Okay. Then there is one more document I have created. What was Docker Shim? Why Kubernetes dropped the Docker support? So this was architecture. If you just consider the communication between the kubelet uh, and then Docker engine, Containerd, and the runc. So just think about it. So Kubernetes, once we trigger or type any command, kubectl create deployment, Kube API server got the request. It stored that information into etcd database. Then deployment controller created, checks with the API server. API server notifies that, okay, there is new request for creating a deployment. Deployment controller will communicate with your replica set. Replica set controller will create a pod, and then at the same time, kube scheduler will also help to find out the suitable node. API server will talk to kubelet and ask to create a new uh, pod and the container. So from there onwards, kubelet receives an instructions to start a container. It will uh, talk to the Docker shim. Then Docker shim kubelet sends these instructions to Docker shim, which translates into a language which Docker can understand, because kubelet can't create a container. We use this entire container runtime framework for creating a container. Right? Then Docker receives the translated language, but does not directly handle the container image. It instead passes that information to the container D, a lower level container runtime, and then container D downloads the container image, prepares the environment. Again, container D is not creating your container. It instructs to runc to start your container. So this is multi-step process to create one container, or when you want to create a deployment or the pod, right? Which was actually taking so much of time. Uh, if we so Kubernetes and sensor community discuss that if we eliminate the Docker, Kubernetes can simplify the container startup process, reducing the number of steps, and it will also improve the performance for starting up your container. Okay. Yeah, so Kubernetes, that is one reason, and the other reason we discussed that container comes with its own network management, volume management, and all unnecessary plugins, which was not required for the Kubernetes. Kubernetes has its own system and the resource management for your network and the volume and other resource management. So how it helped by removing the Docker, and this is the actual answer for what we uh, discussed in the beginning of this video. So after Kubernetes removed Docker shim and the Docker, the process of starting container became very simpler, more efficient, and very faster. So now Kubernetes developers recognize that container D was doing the actual work. So they decided to bypass the Docker and Docker shim altogether. Now Kubelet can communicate directly with your container D. Um, Although Kubelet and container D don't actually speak the same language, container D includes a CRI plugin, so container runtime interface, which works with a gRPC protocol and protobuf, and then that instructions will get translated to the language or the instructions which container D understands. Okay, so which means if any container runtime which understands or follows the CRI protocol, then that can be used as a default container runtime in your Kubernetes cluster. Now, with the fewer components and the translation steps, the process of starting container is very much faster. And this is the performance matrix Kubernetes team has done over the 105 pods. You can see the clear difference and the winner when we were using a Docker 18.03 community engine and with a container D platform. Okay, this is the CPU usage metric and the pod startup policy metrics. So this is a performance improvement, and that is the main reason for removing the Docker and the Docker shim. Um, uh, and one more reason I want to mention is that earlier CNCF and the Kubernetes was maintaining these project Docker shim since they were supporting Docker as a default container engine as a default runtime. That was also overhead to maintain those projects unnecessarily. Um, I think the discussion started in the very early release 1.3 or 1.5 to support multiple container engine, and we discussed that Kubernetes is extensible and it is portable. So if someone wants to use some other container engine such as container D or Cryo, people should be able to use it. But since this entire thing was very hard coded and at the core of Kubernetes, they removed this entire piece of Docker and the Docker shim. Now, any container runtime which um, follows the CRI, that can be integrated with your Kubernetes cluster. So we'll discuss about that in more detail, like how to set up a Kubernetes cluster and then how we can use a container D as a container runtime. And so many interesting videos are coming up. So if you have watched this video till the end, I want to say very thank you. Keep supporting, and I'm looking forward to see you all of you again in the next video.